Dear First Prep, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmad Mahmoud with you today. I am glad to introduce a new mathematics lesson this term, inshallah. The show will be interesting and it will be exciting, inshallah, and it will be very clear for all of you, and it will be very effective in the monthly and final exams, covering all the importance in the school book and the exams. Let's start the first lesson. The first lesson, inshallah, is algebra. It's unit 1, lesson 1. The lesson is called set of rational numbers. First, we have in this term 2 units algebra. The first lesson called sets of numbers, and this lesson we are going to study the rational number and the properties of operations on rational numbers. And in the second unit, inshallah, and will be the very important one, we are going to study the algebra and the algebraic terms and algebraic expressions and so on. This is very, very important. Let's start the first lesson with us. The first lesson, inshallah, will be the set of rational numbers. But before explaining the meaning of rational numbers, we need to remember some sets of numbers. Okay, the first set was called set of natural numbers, n, which included the numbers started from 0, 0, 1, 2, 3, and so on. The second set is the set of integers, z, which included the natural numbers plus the negative numbers like this: negative 3, negative 2, negative 1, 0, 1, 2, 3, and so on. The natural numbers and the integers included only the whole numbers. Okay, so if we have, for example, 0.5, so it's not included inside z. Okay, and if we have, for example, 1.2, also not included in z. Also, they are included only the whole numbers. Okay, now we need to know what the meaning of rational numbers. Okay, the set of rational numbers denoted by q. Its name is q. Okay, the word rational comes from ratio, and ratio is comparing between two numbers. The two numbers written in the form up and down or fractional form. So first we have a set like this. This set included numbers. The form of these numbers written as the form a over b. A over b is a fraction. A is the numerator, b is the denominator. Okay, this fraction has 3 conditions. Okay, first, a must belongs to z and b must belongs also to z. The numerator is an integer and the denominator also is an integer. And the third condition, b doesn't equal 0. The denominator must not equal 0 because the division by 0 is meaningless. Again, the division by 0 is meaningless. Okay, let's explain some examples for the rational numbers. Okay, the first example, if we have 2 over 3. 2 over 3, 2 is an integer, 3 is an integer, so 2 over 3 belongs to q, and also 3 not equal to 0. Another example, negative 1 over 4. Negative 1 is an integer, 4 is an integer, so negative 1 over 4 is a rational number. And if we have negative 2 over 0, here this number over 0, so the value of this number is meaningless, so it doesn't belong to q. Another number, 0. 0 can written as 0 over 1 like this. I can write this one as 0 over 1. So 0 over 1 belongs to q. Another example, if we have negative 4, also negative 4 can written as negative 4 over 1. So negative 4 belongs to q. 5 over 0, because 5 over 0 is meaningless, so 5 over 0 doesn't belongs to q. and Q is the set of the rational numbers. Now it's very clear that any fraction belongs to the rational number except the fraction that is over 0. Okay, now I can write N, Z, and Q by using the Venn diagrams like this. Remember with me the Venn diagrams. The Venn diagram is an oval or rectangle, is a shape included the sets of number. Okay, the first set with us is N, included 0, 1, 2, and 3. If I add the negative numbers outside N, like this, -1, -2, -3, and so on, plus the natural numbers N, all of them included inside a set called Z. So N is a part of Z or a subset of Z. Also, if I added the fractions and the decimals to this set outside Z, of course, like this, it gives me the set Q like this. So N and Z part of Q, or Z subset of Q. So I can say that any any integer is a rational number, but in its denominator is 1. For example, -2 can written as -2/1, so this is a rational number. -1 is -1/1, 0/1, 1/1, and so on. Any natural number or any integer can written over 1, so it will be a rational number or belongs to the rational number. This is the remark that I said. Each integer is a rational number with denominator equal 1. Remember with me, the denominator is the number written down and the numerator is a number written up. Okay, now let's study some remarks about the rational numbers. The first remark with us, for example, if we have 6 divided by 3 or 6/3. 6/3 is a rational number because it is a fraction. Okay, this fraction equal in the simplest form equal to 6 divided by 3 equal to. So this is an integer. Okay, so this number belongs to Z. Okay, so 2 is a rational and in the same time it is an integer. Another example, 10/4. 10/4 in the simplest form, if we divide it up and down by 2, it's equal 5/2. 5/2 doesn't belong to Z. Why? Because 10 is not divisible by 4, but 6 divisible by 3. So I can say that any rational number express an integer only when its numerator is divisible by its denominator. Again, any rational number represent an integer if the numerator divisible by the denominator. 6 divisible by 3, so the result is an integer. Not 10 is not divisible by 4, so the result is only a rational number, not an integer also. Okay, another remark. The other remark, if a/b is a rational number, then the main condition that makes a/b is a rational number, okay, as I said before, b must not equal 0, so b is not equal 0. For example, if we have 3/x is a rational number, so x not equal to what? The main condition that makes this number rational, that x not equal to 0, because 3/0 equal meaningless or undefined. Another example, 2/x minus 4. Okay, what is the number that I write in place of x to give me 0? Number minus 4 equals 0. So yes, it is 4 minus 4. Okay, so this number is a rational number when x not equal 4, because 4 minus 4 equal 0. Again, this number is not a rational number at x not equal 4 because 4 minus 4 equal 0. Let's solve the first example with another remark. If we have a fraction like this, a over b equals 0, we know that the fraction equals 0 if the numerator equals 0. Again, the fraction equals 0 if the numerator equals 0. For example, 0 over 5 equal to 0 and 0 over negative 3 equal to 0. So if the numerator equals 0, then the fraction equals 0. So here a equal to 0. Again, a equal to 0 if a over b equal to 0. And if we have x over negative 5 equals 0. This is for example. So what will happen? So x equal to 0 because x is the numerator. Another example, if x plus 2 over 3 equals 0, again x plus 2 equal to 0 over 3 equals 0, so x equal 1, x equal what? X plus 2, number plus 2 equals 0. What is the number plus 2 equals 0? It's negative 2. So x equal negative 2. I can solve this one as an equation like this. X plus 2 equal 0. So I'm going to send 2 to the right side. So it will be 0 minus 2. So x equal negative 2. You can solve it by guessing, and you can solve it by solving the equation. Both are correct. Let's solve the first example. Example 1 with us. Show which of the following is rational and which of them is not a rational number. Okay, 2 over 3 is a rational number because its fraction and the denominator not equal to 0. 6 over 5 equal 13 over 2, so this is a rational number. 12 and 5 over 6 equal here over 6. 6 times 12 equal 72 plus 5 equal 77 over 6. So 77 over 6 is a rational number. This number 4 over 0, so it is not a rational number. Finally, negative 4 all to the power of 0. Remember with me the power. Any number to the power of 0 equal 1. This is rule. Again, any number to the power of 0 equal 1. So this number is a rational number. So all of them are rational except 4 over 5 minus 5. Another example. Okay, complete the following. If 5 over a is a rational number, so a, here a is the denominator not equal to 0, so a not equal to 0. Number 2, 3 over x minus 2 is a rational number, so x minus 2 doesn't equal to 0. I'm going to send 2 to the right side plus 2. So x doesn't equal 0 plus 2 equals 2. So x doesn't equal 2. Anyone can solve it mentally, it's okay. Or you can solve it by using the steps like this. Both are correct. The number x plus 7 over x minus 3 is irrational. Okay, the condition that the number is irrational comes from the denominator. The denominator must not equal to 0. So x minus 3 not equal to 0 by sending minus 3 to the right side plus 3. So x not equal 0 plus 3. equals 3, so x not equal 3. That means x is any number except 3. Okay, number 4, the rational number 2 over 3x is a rational number, okay, at x equal what? Okay, this number to be rational, so 3x must not equal to 0. 3x means 3 multiplied by x, so I'm going to send 3 divided, so x doesn't equal to 0 divided by 3, so x doesn't equal to 0. Number 5, the rational number 4 minus x over x minus 3 equal 0. The main condition that makes this fraction equal 0 comes from the numerator. Okay, here 4 minus x equal 0. 4 minus what equal 0? It's 4 minus 4, so x equal to 4. Again, 4 minus number equal 0, so x equal to 4. Now let's study the different forms of rational numbers. Different forms of rational numbers. We have a fact or rule we studied in the primary stage related to the fractions. Okay, that fact, if the value of the rational number or of the fraction doesn't change if it's two terms multiplied or divided by an integer. What the meaning of terms? The fraction included from two numbers, the numerator and the denominator. The numerator called first term and the denominator is called second term. Okay, for example, if we have fraction like 2 over 3, if we multiplied up and down by number 5, for example, so 2 times 5 equal 10 and 3 times 5 equals 15, like this. So 2 over 3 and 2 and 10 over 15 are equal. Again, 2 over 3 and 10 over 15 are equal. Okay, so if we multiply the numerator and the denominator by the same number, the value of the fraction doesn't change. Another example, 8 over 14. If we divided 8 and 14 divided by 2, it gives me 4 over 7. So 8 over 14 equals 4 over 7. The value of the fraction doesn't change when we divide up and down by the same number. Okay, now let's study the first question. The next question. Example 3. Complete the following such that express a rational number. Okay, 3 over 4 equals 9 over what? Okay, I can solve this one by 3 times what equals 9? 3 times 3. And the 4, and I'm going to multiply 4 times the same number times 3. 3 times 3 equal 9, and the 4 times 3 equals 12. So here we have 12. And also 4 times what equal 8? 4 times 2. So here 3 times 2, 3 times 2 equals 6. I can solve this one by another way, by using the cross multiplication. How come? 9 times 4 over 3, again 9 times 4 over 3 equal 12, and 8 times 9 over 12 equals 6. Again 8 times 9 over 12 equal 6. So you have two different ways. You can use the cross multiplication, 9 times 4 over 3 to give you 12, and 8 times 9 over 12 to give you 6, or you can use multiply up and down by the same number. Both are correct. Okay, Example 4. Put each of the following in the simplest form. Okay, here 15 over 25. If you keep the timetable and you know that 15 and 25 both divisible by 5, so it is equal 15 divided by 5, 3, and 25 divided by 5 equals 5. Or you can use calculator directly like this. Okay, like this. 15 over 25 equals 3 over 5. You can use any of the two ways, by calculator or by simplify. Okay, the next one, 45 over 20. 45 and 20 in table 5, so I'm going to divide it by 5. 45 divided by 5 equals 9, and 20 divided by 5 equals 4. Okay, write each rational number in the form a over b. Okay, here we have negative 5. Negative 5 written as negative 5 over 1. Next, 0.75. 0.75, you can use your calculator, it will be 3 over 4. Next, 30%. 30% equal 30 over 100. The percent is over 100. Or you can use it, you can put it in the simplest form to be 3 over 10. Number 4, 8 and 2 over 3. I'm going to write down 3. 3 times 8 equal 24 plus 2, 26. So it will be 26 over 3. Or you can use calculator. Remember with me like this. Remember with me, shift fraction. Again, shift fraction like this. And I'm going to write 8 and 2 over 3 equals 26 over 3. You can use any of the two ways, both are correct. Now let's study the recurring decimal. The recurring decimal, or it's the meaning of the word recurring is repeating decimal. What is the recurring or the repeated decimal? For example, if we have 0.3 dot, 0.3 dot, the dot written above the number, the repeated number, that fraction means 0.333 and so on, like this, with no end. Okay, now I need to change this fraction, this decimal, into fractional form like this. Okay, I'm going to write 0.3 and I'm going to repeat 3 until the appearance of the black arrow, this one. So I'm going to press equal. It gives me 1 over 3. So this fraction equal 1 over 3. Another example, 0.25. 0.25 means 0.25, 25 and so on, like this, repeated 25, excuse me. So it is equal in the calculator 0.25 until the appearance of the black arrow. So I'm going to press equal. It gives me 25 over 99. Another example, 0.134. The dots here above 1 and 4. So I'm going to repeat the whole number, 3, 1, 3 and 4. Again, if the dot above the first and the last, so you are going to repeat the whole number. So it will be like this, 0.134, 134, 134 and so on. Okay, in the calculator it will be 0.134 Okay, equal 134 over 999. Another example, 0.134, but the dots here above 3 and 4 and not the number between them. So I'm going to write 0.1 and I'm going to repeat 34, 0.134 and the dots above 3 and 4. So I'm going to repeat 3 and 4 because the number there isn't a number between the two dots. So it will be like this, 0.1, 34, 34, 34 and so on. I'm going to write it in the calculator like this, 0.1, 34, 34, 34, 34, 34 and 34, 34 until the appearance of the black arrow. It will so equal 133 over 990. Okay, like this. Let's solve the next question. Okay, now we have example 6. Write the following rational numbers as a decimal and a percentage. Okay, as a decimal, this one approximately equal 1 over 6 equal, and S to D 0.1666 and so on. So 6 here is repeated, so it will be 0.16 dot. If I multiplied, to change this number into percent, so I'm going to multiply by 100, 0.16 dot times 100 equal 16.6 dot percent. Okay, number 2, negative 3 over 20. Negative 3 over 20 equal negative 0.15. This is by using the calculator. And when we multiply this one by 100, 0.15 times 100 equals negative 15%. Number 3, 5 over 9. 5 over 9 equal 0.5555 with no end. So it is equal 0.5 dot, like this. And when we multiply this one by 100, so it will be equal 55.5 dot percent. Number 4, 16 over 3. 16 over 3 approximately equal 5.3333 and so on. So it will be 5.3 dot times 100 equal 533.3 dot percent. Okay, example 7. Number 1, express 0.77 as a rational number. So it will be by using the calculator 0.575757 and so on equals 19 over 33. Number 2, 0.32 dot. It will be 0.3222 with no end equal negative 29 over 90. And number 3, if negative 4 over 5 equal 20 over x, so x equal 20 times 5 over negative 4 equals 20 times 5 over negative 4. This one equal negative 25. Or another way, I can here 4 times what equal 20, 4 times 5, so I'm going to multiply up and down times 5. And the negative here comes down, negative 5 times 5 equal negative 25. You have now two different ways. The next question. Okay, write the rational number that equals to 3 over 5 and the sum of its terms equal 24. Okay, this number is the first and this is the second, so I'm going to write it as first to second to sum. Why I write here sum? Because he asked me the sum of the two terms equal 24, and the terms here means first and second, 3 and 5. So here 3, here 5, their sum equals 8. And he asked me the sum of the new number is 24, so it will be 24, like this. The first number equals 3 times 24 over 8. Again, 3 times 24 over 8 equals 9. The second term equal 5 times 24 over 8 equals 15. Then the number is 9 over 15. And this is the end of the lesson. I hope it was helpful for you. See you inshallah in the next video. Assalamu alaikum wa rahmatullah wa barakatuh. Mr. Ahmed Mahmoud was with you.